work or anything? Everybody okay out there? All right. Ethan's voted. Ethan's doing good. Nobody else wants to talk to me. Nobody else wants to show me they're a human person.
The test was relatively easy, I thought. So I thought that went really well.
Okay, well, that's my hope. We'll find out. And it was just a quiz, unfortunately. Didn't count that much. All right. I appreciate Trisha. She's driving and she turned her camera on so she could try to keep her instructor sanity going a little bit longer. Always nice. Okay, if no one has, this is, again, I keep trying to build in time to handle questions because there almost has to be questions. I know if you're doing the homework, you have questions. So if you don't have questions, you're not doing the homework. I mean, that's the bottom line. Because some of the homework gets a little freaky sometimes. So, all right, if nobody has questions, we're just going to keep on going. Let's see. So last time we did an example of the last kind of word problem that we hadn't looked at yet. Now is the mixture problem. Remember that? We looked at a mixture problem. We were mixing raisins and M&Ms. We were mixing peanuts and something else. I don't even remember what the hell it was. Cashews? I don't know. And we're talking about the price per pound and how that would change if I mixed two things together that had different prices. All right. Does that ever happen? Yes. So if you own a store and you have to purchase these things in bulk and you want to make mixtures for people, you kind of want to know what your price point should be, right? So that would be how you would figure it out. Okay. Blah, 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 blah. So I'm almost certain there's not a lot of people that have tried section 3.5 yet because, for example, number 7 is kind of freaky. So eventually when you get there, I'm going to get questions on that. And number 8 comes off in number 7. So we'll see. I'll wait and see if anybody does it and ask questions. So let's see. We're going to get back into section 3.6. And we're just going to kind of step through the group work part of 3.6. All right. Pop, pop, pop. So let me do this. Shabow. All right. So they get stuck on things. So we got stuck. Remember when we got stuck on snow cones? The book just loves snow cones. All right. So now we're eating our snow cone in a cab. So now the book kind of loves being in a cab. I guess the book maybe just mainly loves Vegas. I have no idea. Right. So if you ever find yourself with too much money, once the pandemic is over, go to Vegas. There's all kinds of ways to not have much money after that. So one way is to take a cab. That's a quick way to lose some money. It could be a quick way to lose your life. So be careful. So here's the thing. I haven't really defined direct variation, excuse the pun, directly. But here's what direct variation is. And let me just show you where it talks about it in the book. So direct variation is when you can write the relationship in this form right there. Do you guys see that? So if you can write the relationship as y equals something times x, that's direct variation. That's exactly what I said yesterday. I just didn't write it in math form. Maybe. So I really want you guys to understand. So for example, if I had y equals 3x, does y change directly with x? Yes. If x is 1, what's y? Your time to shine. If x is 1, what's y in that equation?
3.
3. Holy shit. Now somebody else. If X is 2, what's Y?
6.
6. I'm giving you a chance to shine here. Somebody else. If X is 3, what's Y?
9.
9. Holy shit. So are both X and Y changing as I move down this chart? Is one changing directly as the other one changes? Yes. So how much does Y change as the X changes? Y changes by 3 as the X changes by 1. Right? More importantly, all right, let me see if I can. The important distinction to make is it has to be in this form. So what will you always get if you put a 0 in?
A 0.
A 0 out. I love it. Which means, stay with me now, the y-intercept, the y-intercept for a direct variation problem always be 0, 0. What? That was weird. All right. Oh, let me see. I've never done that. Oh, that's so cool. I had no idea I could do that. Sorry. All right. Learning new things about Zoom every day. So let me clear all this. So let me ask you this. Let me see who just took good notes or paid attention at least. Is this, let me write down this, remember this equation we used in the homework? C equals 5.10 plus 2.6 m. Remember that equation? Good old CAB equation? You don't if you didn't do the homework yet. Is this direct variation?
No.
Oh. Does anyone agree with Trisha? I do. I agree with Trisha. Does anyone agree now? Nobody, really? That's the time to say, yeah, I agree. When the freaking teacher says,
Yeah,
I
I
agree.
agree.
Yeah, even if
I
I'm
had a
wrong.
mouthful of cereal. I'm sorry.
You're fine. I'm just really worried that not everybody's really here. All right. Oh, yeah, all right. Let me see. Sorry, hold on. Let me double check. All right. Okay. Now somebody else that I haven't heard from yet. Can you tell me why this is not direct variation? Somebody. Why is this not? Go ahead.
Because they don't have the M after the number,
It does right there.
but the 5.10 doesn't. Wouldn't it have to be the same?
There you go. It's got an extra piece. Does this look like y equals kx? No, it's got an extra piece. If I put a 0 in, will I get a 0 out? No. Okay. So to be direct variation, it has to be in this form. All right, good. That's all I'm going to say. I really want to make that clear, but it's not like a huge part of math. So I don't know. I just want it to be clear, understood, but it's not like this is the main thing of math. No, stop. Okay. So let me clear this. Go away. Clear. What do you think about this? Here's something that has no equation with it. Do you think the amount spent at a gas pump and the number of gallons of gas purchased are quantities that vary directly? Would there be direct variation between the amount you spend and the number of gallons you get? Would that be direct variation?
Yes.
Yes. Why?
Because 0 money, 0 gas.
That's the quickest way. Is to, sorry, I just got a note. Yeah, we can talk after class. Let me say it again. Yeah, that's the quickest way to check if something might be direct variation is to realize that 0 in is 0 out. But let's say, has anyone gotten gas recently? How much does it cost out there?
I just
Roughly.
got it for 4.03 a gallon.
Holy shit. All right. I don't want to All right, let's see. So let's say $4 a gallon, right? Yes, yes, yes. So how much would I spend if I got G gallons? G gallons, spend S. So how much would I spend if I get G gallons? I'm missing something here. If I got 1 gallon, I would spend how much money?
4 times G.
40.
Yeah, 4G, right? 4G, just like your old iPhone. I know, it's a dumb, yeah, I know. Thanks for the courtesy chuckle. All right. So that is definitely direct variation. One letter is a multiple of the other. One variable value is a multiple of the other variable value. Okay, okay, no big deal. So let me clear this away. Clear. Let's say you stop in at the local gas station just to buy an energy drink and don't pump any gas. Oh, this is kind of dumb. How much would you pay for 0? You would pay 0 for the gas, but you'd have to pay for the energy drink. So this is a weird question. I don't know what they mean. All right, so 5 gallons. All right, I don't know. So this is obviously not California, or maybe not 2021. If 5 gallons of gas cost $11.10, how much would you pay if you bought 10 gallons? That's going to be a relatively easy question, right? 5 gallons is 11.10. 10 gallons would cost how much?
22.20.
22.20. So that's the fantastic thing about direct variation. You can answer those kind of questions pretty quickly. And of course, if you cut the amount in half to 2.5 gallons, somebody else tell me, what would 2.5 gallons cost? You can use your calculator, of course. Hello, anybody? So if 5 costs 11.10, 2.5 gallons would cost how much?
$8.88. Is that wrong?
That's wrong.
Okay, sorry.
That's right. I'm just curious, how did you get that? What did you do? Or you don't want to tell me? You're like, it's wrong, dude. Leave me alone.
I know. I looked at how much 10 gallons cost, which is $22.20.
Oh, I see what you
And
did.
then I looked at how much 1 gallon costs, and that
Ah,
was way off. I shouldn't have done
that
that.
would get you to 4 gallons. 4
Yeah.
gallons would cost $8.88.
How much are we supposed to try and find?
2.5.
2.5 gallons? Oh, okay.
So if 5 gallons cost 11.10, if I cut this in half, what do I do to this?
Nothing.
Cut it in half. And what do you get when you cut that in half?
5, 55, yes?
Yes. You gotta love these numbers in this problem,
Okay.
right? 888, 555. Look, this is 111, 222, 555, just with the decimal moved. All right, sorry. So what Tristan did, I think, who was talking to me, is he figured out basically what the slope was. And I think maybe they're gonna eventually get there. Can somebody tell me? Somebody hasn't talked to me yet. What the slope is. What's the rate? So what that really means is 1 gallon costs how much? How much per 1 gallon? It's not too difficult to figure out. If 10 gallons cost $22.20, 1 gallon is going to cost how much? If 10 cost $22.20, 1 gallon costs how much?
220? Wild guess.
Almost is 222, right? You just move the decimal back once. You just divide. If I divide this by 10, I have to divide this by 10. Yes, yes, yes,
Yes.
yes. Okay. So now we can answer this question pretty easily. I'm just going to kind of circumvent the book's steps here. Take a minute, don't say anything, figure out exactly how much would 15.2 gallons of gas cost in this fictional state or this other year or wherever 222 gas exists. Does everybody understand the question? So you're working right now. You don't have to say anything. Just want to make sure everybody understands what's happening. How much would 15.2 gallons of gas cost in this fantasy land? How would you figure that out? Somebody tell me.
Multiply 15.2 times 2.22.
Yeah, it makes sense. You can even think of it as a conversion, right?
I was thinking like super complex. I was like, well, if we add 5.5
Oh my goodness.
plus 5.55, and then we take that and we add that to the 10 gallons, then
Oh my
then
gosh.
we can answer.
You get kind of close. Now watch, if you add 5 gallons for 1110 to 10 gallons for 2220, you get 15 gallons for 3330, correct?
Yeah.
But then you got that 0.2.
Mhm.
Yeah. Anyway, so what do you guys, anybody can tell me what this is? You don't have to think of it. I'm sorry. Go ahead.
33.744. That's what I got.
33.744. We'll make it a normal amount. Gas, I don't know if they would round up, probably. What am I trying to say? I almost had it. Oh yeah, you don't have to think of this as a conversion, but it's kind of nice how everything kind of works together. So what is the equation for this then? The price, how do I want to say this? Oh, I don't know what they're going to use eventually. So the gallons of gas, we'll use G again for the gallons of gas. And the amount that we spend, sure, we'll use S, I think is what I used. So what's the equation for this specific gas station? What goes here? To figure out
2.22?
Yeah.
The number for the gallons.
2.22. Yeah.
Oh, yeah.
So that's in the form y equals kx. And we now know, I keep telling you this, that this is the slope, which is the rate of change. All right. Okay. All right. I'm going to clear all of this away. Clear. Okay. Let's see. They did something weird in 6, so we're just going to skip that by. Barf. Look at number 7. Oh yeah. So this is still talking about the gas and the whatever. So we already finished all that. We're good. Blah, 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 blah. Blah, 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 blah. Blah, 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 blah. Sorry. This is, the book is finally catching up to, oh man, people are chatting at me. I can't take it. All right. So guys, we figured out the equation was the amount that we spend is 2.22 times the number of gallons. So we've seen this kind of thing so many times in this class, right? You give me an equation, I can kick the shit out of a table, right? Just throw a number in, plop a number out, throw a number in, plop a number out, blah, 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 blah. I'm using the letter S from before because that was the amount we spent. I could use the letter C, I guess, for cost. All right, so there's nothing really interesting to get from this, to be honest. I'm going to clear all that. Okay. This is old news. Once we create an equation, we can make an XY table, which is all this is. Inputs, outputs. 14 is a little bit more interesting of a question. So let me see. Let's put this down here. So let me use C instead of S. The cost we know is 2.22 G. If you pull up to a pump and you see this on the pump, can you take a minute and not say anything yet? Figure out how many gallons the person before you bought. If you're in this fantasy land of $2.22 a gallon gas. All right, so somebody help me out. What would you do with $40? Where would you put that?
Where G
What does
No,
G
that's-
represent?
gallons.
Gallons. Oh shit. So where would 40 go?
C.
Yes. C. So now how do you figure out how many gallons? What do you want to get rid of? Sorry?
40 divided by
Yeah. I
2.22.
want to get G by itself. What up, G? And so I want to divide by the stuff that's in front of it. So I get whatever the hell this is. Am I going to really do this in my head? Are you guys not going to save me? I don't know.
18.018.
So like 18.02, we'll just say gallons roughly. So about just a little over 18 gallons then, right? Okay. All right. All right. You ever pull up to a gas pump and you look at it like, what the hell kind of thing are you driving? 36 gallons. How do you buy 30? Anyways. Let me clear this away. So we've done this stuff before. So this section's sort of like a, I don't know what you call it, kind of a refuse section. It introduces the idea of direct variation, but it's basically a specific type of equation. And we've already kind of looked at more general equations. So this section really shouldn't be a horrible section to do. Oops, sorry. I want to skip. Crappity doodah. All right. Barf, barf, barf. Okay, that's nothing we need. All right, here. Yeah, okay, I like it. So 15 is a beautiful problem. Do 15. Don't say anything. Try to do number 15. What the what? Damn gummit. All right. Weird things happening. So one way you can do this. Oh, there's chats happening. Oh, that's from before. I'm sorry. All right. So, all right, now watch. There's two main ways to do this. Let me show you kind of a different way. Here's pay, and here's the number of hours you work. So wouldn't the answer to the equation look like this? Is that cool, everybody? It would look like P equals KH, right? It's got to have the form Y equals KX, but I'm not going to use Y because I want to call it pay, and I'm not going to use X because it's hours worked. Now, what information do they just tell me? What do I know for certain? What situation do I fully know everything?
That you worked 14 hours and you made $163.
So when I work 14 hours, I make $163.80. So can you solve for K? For K? Now, didn't some of you guys do this at some point to figure out kind of like the slope, right?
Yes.
Or the rate of change, or yeah. So I mean, this is kind of a nice, kind of like formalized way to do it. Set up what the equation will look like, plug in what you know, and then solve for what you don't know. So somebody help me out. What do you get when you divide these? Is it 11? No.
I got 11.
Yes, 11.7.
11.7?
Yes.
Yeah.
Yes.
And what are the units on that?
Dollars per
Dollars?
hour.
Yeah. Dollars per hour. Always look what goes into creating something. What went into creating K? Dollars divided by hours. So it's dollars per hour. Rate of change, slope. So now what is my equation then? I can put all this stuff together and I get P equals 11.7 H. $11.70 an hour. That's good, right? It's almost what minimum wage should be if it kept up with inflation. I think it should be like 20 something dollars an hour if it kept up. Anyway, that's a whole other thing. And then how do you do this? Is that hard? Now that I got this thing?
You just plug in the 20 to H.
Yeah. So to do the 20, I would do 11.7 times 20. And that, of course, would be 234. Is that right? 20. What is that, Jeff? $234. Is that right?
That's right.
Yes.
Look at me go. Look at me go. And of course, again, you just plug in, get out of there. Plug in 25. Do that fast, math boy. Be quiet. It's not nice. I don't know what the hell that was going to be. What is that? 58, 292 point something?
5.
0.5.
What is it?
292.5.
Oh man, I suck. Sorry, guys. All right. All right. So a lot of this should feel very familiar. We're just sort of really connecting the idea of rate of change, becoming the idea of slope. You can see it in this little direct variation equation. Okay. Now look at, I like 16A. Are they catching up with what I did here? I'm curious. Take just a hot second and solve that for K. Solve this equation for K. All right, I'm going to clear this away so I can move down. Clear. All right, so how do you solve this for K? What do you do? Uh-oh. All right, I like it. Somebody gave me the answer in the chat. How do you get K by itself? I got to divide by what?
X.
Good, divide by X. So I get K equals Y over X. What does this tell you about the ratio fraction involving X and Y? Blah, blah, blah. This K variant. Oh, this is so stupid. All right, so this is basically what we just said a minute ago. Sorry, I'm kind of like critiquing the book as I go. This is related to the slope. This is the rate of change. You can tell what the units are because you know the units for these and you know the units for those, like we just did with the dollars per hour for number 15. Okay, so let me clear this away. Clear. Oh my God, what is that? Get away. I don't, let's not talk about that. All right, so let's take a look at the, oh, I love this. All right, guys. So exactly one of the, well, anyway, I'm not going to say anything. Don't you say anything either. Take a minute, look at each of these problems and tell me if they are an example of direct variation or not. All right, now how in the world can you tell? Well, remember, what's one of the ways I said you can quickly identify if something is direct variation or not? What if it is direct variation, what must you get when you plug a 0 in?
0 in.
0.
0 out, right?
Yeah.
That's what direct variation really means. If I work 0 hours, I get 0 money. If I, whatever. Does that help figure out how many of these, which one is not direct variation?
24.
34.
24 is not. These two are, because they go through 0, 0. And more importantly is these are straight lines, right? Because would this equation be direct variation? It's a very simple answer because we said that it has to look like this. So does that look like this? No. So if it's basically I can put whatever power I want to. So if there's any curve to it, doesn't matter if it starts at 0. If there's a curve to it, no. That's not direct variation. That means that one varies with the square of the other one. It doesn't directly vary then. Okay, maybe. So it's got to be linear going through 0, 0. That's what direct variation is. All right, so let me clear all this away. Clear. Okay. So let's take a look at the homework. Let's see what that weird stuff's gonna look like. So you gotta use the internets. All right, gotta complete the table. That should be pretty straightforward, I would hope, right? Then you have to write an equation, so you can do the thing we did just a minute ago if you want to figure out what k is, or you can think of it as finding the slope and putting it into the equation. You guys with me? So we did an example just like number 3. This kind of goes back in time a little bit. Remember independent variable and dependent variable? So can somebody tell me in the equation which one is the independent variable? And which one is the dependent variable? Does anyone remember?
Would independent be the American dollars?
No. Don't look at this. Don't look at this. Look at this equation. Sorry. Y equals kx. So y and x. Which one is the dependent? Which one is the independent?
Y is the independent one because it's on its own, and X is the one that's attached to another variable.
That's
That one's the dependent.
That's an interesting way to look at it, but that's not quite right. I want this to make a ton of sense. Y depends on what X is. I have to know what X is first. In fact, what would you normally, so if I gave you an equation, let me make it something specific. Let's say I make $9 an hour. So I get paid 9 times the number of hours I work, correct? So what do you normally choose as the input? What can I just pick? I can just pick a value for H out of thin air, right? I can make H3. And then my pay depends on the number of hours I worked, yes? Because it's some multiple of the number of hours I worked. So this one will be the dependent variable. And this one is the independent variable. And again, that's really not that important in the grand scheme of things, but okay. Okay. So look at number, let's see, blah, 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 blah. Oh yeah, so then you have to convert something from American dollars to yen. No worries. Clear this away. All right, so this doesn't look like it's going to be too horrible. It's going to get a little more interesting down here. Look at that. Yeah. And then I will warn you, was there a really weird one in here? Yeah, this gets a little bit interesting with the scale of a map. But anyway, so you got to get in there and try it out and ask questions if it gets too weird. So let's do a little preview and then we'll call it a day because I had a chunk of time set aside for questions, but nobody had questions. So what we're about to get into is finally formalizing the equation of a line. We're going to figure out how to find the equation of a line given different kinds of information. And then we're going to do some more graphing. So, I mean, everybody who hates graphing, oh well, I'm just going to deal with it. Here it comes. Some more graphing. So that's in our future. We're not going to do any experiments on different levels of alcohol and how it affects us. That's completely on you. You can do your own experiment if you want to. I'm not condoning it or sanctioning it, but especially if you're underage. Now, that's enough right there. This is a very early class because nobody had any questions. What is K? I'm not sure what that question is about. I missed it. Did you want to?
It was about the independent variables. If y
Oh!
is dependent on x, then what is k?
Is K a variable? No.
No.
It
Okay.
is a specific value given the situation, right? So, so K for K in a case where I'm getting paid for a job, I could get paid at a different rate than you. So your K is different than mine, but for each of us, it's a constant. Does that make sense? Let it make sense. Your rate of pay at your job right now is a constant, correct? Okay. Right. Now mine, I don't get paid per hour. I'm salaried. This is the goal, right? Yay, I'm salaried. But I did have pay, and I'm not talking about when you get a raise, then your K changes. But that's a new equation now in your new situation. I really want this to make all the sense in the world. Things like the slope, which is what K really is, they're not variables in the sense that I couldn't even figure out what X makes Y if I didn't know the value of K. Right. So
Okay, that
K
makes
has
sense.
to be kind of figured out before I even have an equation. Does that make any more sense?
Yes.
Okay.
Thank you.
If not, I was just going to keep babbling. All right, guys. Really early class today because nobody brought it. So maybe bring it tomorrow.
I'll bring some questions tomorrow.
Good. That will help everybody. Okay, thanks. So especially in 3.5, just get in there, try some shit out, and oh, I'm sorry, is the little dude still there? Try some stuff out, and just bring your questions because some of those questions get weird. So I am here for answers. That's the point of this class. So let me know if you need to hang out. Otherwise, you're free to go.
Thank you.
Thank you, Professor.
Certainly. Oh, I don't want her to hear from me at all like that. All right, let's see. You guys okay? I know Guillermo has a question. Tristan, are you out there? You okay, Tristan? All right, I'm gonna move you away.